Today what we did is we did a card sort, characterizing graphs on what they look like. And then we took a couple notes. We talked about the degree of a polynomial. And we said the degree of the polynomial is the highest power. And we also discussed what the leading coefficient was. And the leading coefficient is the coefficient of the term, coefficient of the term with the highest power. And we looked at a couple of examples here. We said, what if f of x equals 5x to the fourth minus 3x cubed plus x plus 2. And we said our highest power is 4, and the leading coefficient is 5. So our degree equals 4, and I'll write LC for leading coefficient is 5. But we also talked about how it doesn't necessarily need to be in that order, from highest to lowest, those powers. You might see one that's like negative 2x squared plus 5x to the third minus 7x to the fifth plus 2. We always have to look, so here's our highest power, so this would be our leading coefficient. So the degree is 5, and your leading coefficient would be negative 7. So in our card sort, we categorize these into shapes. And then we categorize them, we called them field goals facing up and down, parabolas up and down or not, and then some bendy straw ones going up and down. And we were able to determine that if your leading coefficient is positive and the highest degree is even, all of them, they ended like a parabola. There might be some weird stuff going on in here, but the ends were the parabola. So if it is positive leading coefficient and an even power, such as, let's take a look at one here. Maybe we had x to the 6th plus 5x to the 5th minus x to the 4th minus 21x cubed. So again, we were saying here's our even power, and it's positive. The end behavior, this graph, it might have a lot going on in the middle, but it ends like a parabola. And the way we describe this, instead of saying field posts or a parabola facing up, end behavior, as our x values go to infinity, what happens to our y? So it's kind of like saying on here, as x gets bigger, y also gets bigger. So we say y goes to infinity. Then we can say go the opposite direction as well, as x goes to negative infinity. So as x goes backwards, goes to negative infinity, it is also going, y is going positive. So y goes to positive infinity. The same thing we looked at for, let's take a look at the one right below that, when it is even and negative. So for example, negative 2x to the 4th plus 3x squared minus 5. So here's our power, but that coefficient is negative. So this one, it's a parabola again at the ends, so stuff's going on in the middle, but both ends are facing down. So our end behavior here, and end behavior always starts as x goes to infinity, and then we also want to know as x goes to negative infinity. Well, what happens here? As x gets bigger, our graph ends up going down. as x gets smaller, our graph is also going down. So both of these would be y goes to negative infinity. Erase that. That should be negative infinity. And then we categorize some other ones. A lot of people called them bendy straws. And a bendy straw was when it was odd. And there were two bendy straws, when it was positive and then another when it was negative. So a positive one, maybe we have x to the 7th plus 2x cubed minus 5x squared plus 2. So we have that highest power being 7, and it's positive. So this was a bendy straw, meaning kind of looks like an x cubed. And again, it might have a lot of stuff going on in the middle, but what we're concerned about is these ends. So again, we have as x goes to infinity, what happens to y? And as x goes to negative infinity. So if we look at this here, as x gets bigger, y goes positive. As x gets smaller, y goes negative. So as x gets bigger, y also gets bigger. As x gets smaller, y is also getting smaller. And then we can take a look at one last one here. If it is odd, but it is negative. So for example, negative 3x to the 5th minus 5x squared plus 3x minus 4. So it's a bendy straw, but our bendy straw starts high and goes low. So this one, let's see, as x gets bigger, as x goes smaller. And let's take a look here. As x gets bigger, our graph is going down. As x gets smaller, our graph is going higher. So it gets bigger, y is getting smaller, and as it gets smaller, y goes to infinity.